Welcome to the last episode of the Junior PenTester training series, and in this particular video we are going to wrap up the privilege escalation module by talking about Windows privilege escalation. The overview for this specific room inside of TryHackMe is obviously, as always, the intro. Then we just talk about what Windows privilege escalation is as a whole, what the concept is, which I'm pretty sure you'll kind of already guess, you can guesstimate what that would be. We're going to be talking about harvesting passwords from the low-hanging fruit, kind of like the easy stuff that we can get, the usual spots, other quick wins, abusing service misconfigurations, abusing dangerous privileges, vulnerable software, and the various tools that we can use to automate most of these things right here. Because as you may have already noticed, we talk about the basics, the actual foundations of what you can do if you didn't have access to any of those tools. But then to make your life a little bit easier, there are tools that can do most of these things in an automated manner. That being said, these tools won't replace you as the analyst, right? They can make your job easier, they can make your life a little bit easier, but they can miss things. There will be false negatives, there will be false positives. So there are a lot of things that you still need to know how to verify as the human sitting behind that computer, and that will be kind of like the final note of this whole thing. And by the end of this video today, we will have officially wrapped up the Junior PenTester training series, which is a part of the Junior PenTester pathway of TryHackMe. Now, that being said, this platform that we're on today is the TryHackMe platform. The room that we're going to be doing is created by Munra, and this is actually a subscriber only room, meaning you do need a paid membership with TryHackMe to actually pull this off. But the nice thing about it is that most people that I know have some kind of a Windows computer. So for the most part, I think everybody has access to a Windows computer. I have one in that corner over there. I record on this Mac, and then I have a Kali Linux box that is installed on this little thing right here. So there are a lot of different operating systems in my life, and I hope that at a certain point you will do the same thing for yourself, because you can get Kali Linux for free installed on a thumb drive. You can get a Mac computer for pretty cheap, honestly, on eBay or something like that, so you can do the Mac OS exercises. And Windows computers are also very cheap. The one that I have over there is actually a really fast computer, but it's like a mini computer, so it's literally like that big. It's very, very small. It might be an inch and a half tall, and it's like about that big. So it's this little box, but it's very powerful. It works really quickly. It has a really strong GPU inside of it, or I guess maybe not really a GPU, but the RAM inside of it is really high, and the CPU is also really powerful. So it's a powerful little computer, and I got that off of Amazon for like $250. So you can get a great Windows computer. The monitor could be like $50. All of that. I'm kind of digressing here, but basically the whole point is, if you have access to a Windows computer, if you have access to a Linux computer, then you'd be solid. And even to make your life a little bit easier, if you have access to a Windows computer, you can install Kali Linux on a thumb drive for free and then run the Linux off of your Windows computer. So technically you can have two operating systems for the price of one. So, and then that will cover pretty much every single video that is on this channel right now, every single video that we're going to be doing for the near future. And at some point, I will most likely go into specific content for Mac OS, but for the most part, everything is going to be either Windows or Linux, and you can get both of those for less than $300 total. So hopefully that'll give you a little bit of hope. And I say all of that to say you don't necessarily need access to the TryHackMe membership, although I think you will get a lot of value for that $12 or $14, whatever it is that you would end up paying for it. I pay for it for the year because they give you a discount if you pay for the year up front. So, but I think monthly it's like $12 or $14 USD. So that all being said, the timestamps for everything that we're going to be talking about today is in the description below. So if you want to skip to any particular part, you can go ahead and do that. There are going to be several virtual machines that have been assigned to us, which is what these little green buttons are that you can see right here. Each one of these elements are going to have a virtual machine attached to it. And then of course we have the attack box that will also be available, and I always use the browser-based attack box to do all of the exercises because the configurations have already been done. I know that it's a strong Linux machine. It has all of the things that I need, all of the tools that we'll be talking about pre-installed on it, and Kali Linux for the most part will also have all of these tools for cybersecurity and pen testing installed on it. So that's pretty much it. That's kind of like it's a deeper overview than I usually do, but I think it's because it's the last video of the series and I just want to make sure that I give you as much as possible when it comes down to information, so you'll have everything that you need to go from this training series to the next path, whatever the path is that you want to pursue. And that's pretty much it. So a quick little note from Hackaholics Anonymous, and we will dive deep into the content. If you're serious about your SciSec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into Windows privilege escalation. Okay, as usual, what I'm going to end up doing is I'm going to go through the course contents. Usually I skim through the contents. For example, I'm going to skim through the introduction. But because this is a detail-oriented room, and majority of the exercises that we're going to be running will have very specific instructions for us to execute, when it comes down to those pieces, I'm going to read those verbatim. But some of the pieces, I know pretty much what they're going to be saying, so I'm going to either skim through the paragraph or I'll just like read the first sentence and we'll kind of skip through it. But for the most part, the next few pieces, the next few tasks inside of this room, I'm just going to go through word for word because I do want to make sure that you understand what the instructions are in case you're actually going through this room alongside with me and you just want a complete breakdown of every bit of instruction that they give us. And then just to make sure that I personally don't miss anything either, because I do want to hopefully get through this entire video recording session in less than 3 hours. The last 2 inside of the privilege escalation module took me more than 3 hours to record, and it was painstaking and it was very grueling. So I'm going to try to see if I can do this in record time, so to speak. So, okay, during a pen test, you will often have access to some Windows host with an unprivileged user. These users hold limited access, including the files and folders only kind of reading, and they have no means to perform administrative tasks on the host, preventing you, the hacker, from having complete control over the target. So what we're going to be covering in this video are the fundamental techniques that you can take to elevate your privileges in a privileged environment, in a Windows environment, hence the whole module being called privilege escalation, right? And this will allow you to use any initial privileged foothold, or unprivileged foothold, I should say. So any initial low-level user, basically, to escalate to an administrator account whenever and wherever possible. If you want to brush up on your skills, there's the Windows Fundamentals module or the Hacking Windows modules that are available. Windows Fundamentals is something that I have recorded previously. I don't know if I've done Hacking Windows. So Windows Fundamentals, let's see if the check marks are there, the green check marks. And they are, so definitely these exist on this channel. You can go search for those names and you'll be able to find them. Windows Exploitation Basics, I've also already done, it seems like. So all of the Metasploit videos are actually inside Jr.PenTester. The Active Directory Basics, Windows Fundamentals, all those are available on this channel. And even this exercise, the blue exercise, it's called blue. If you search for blue, I don't know if you'll find it, but if you search for Windows, there's also a Windows playlist on this channel. If you go through that, you might be able to find the video, but it's basically a practical exercise that goes through the very, very basics of hacking into a Windows machine and manipulating a Windows machine. So I think for the most part, most users are very familiar with Windows because the first computer I was ever introduced to was a Windows machine. And I think for the most part, that's kind of the experience with a lot of people because the Windows license is available for all computer manufacturers except Apple. So if you buy an Acer computer or if you buy a Dell computer or anything like that, they all come pre-installed with Windows. And I think for the most part, again, I think most people are very familiar with the fundamentals of a Microsoft Windows computer. So I think you'll be able to hang with this video as we go along. So let's go into the concept of Windows privilege escalation. We've already talked about privilege escalation several times in this module, but just to review it, this is the concept of using given access to a host with user A, for example, the low-level person, and leveraging that to gain access to user B by abusing a weakness in the target system. While we usually want user B to have admin rights, there might be situations where we need to escalate into other unprivileged accounts before actually getting admin privileges. Now, this specific thing we actually talk about, there's this tool in CompTIA Pentest Plus in the training series, and it's called Bloodhound. And it's really handy because it will pave a path for you. It'll basically say, go from the current user that you're in, then go to this other user in this domain, then go to the next one, and it'll literally outline the path that you need to take to go from all of these various users and end up at the final user, the final boss, so to speak, with the highest level of privileges. So Bloodhound will actually kind of outline that path for you, and it'll map it out, and you'll be able to know which users you can hack so that you can finally get access to the boss user, the admin user. So gaining access to different accounts can be as simple as finding credentials in text files or spreadsheets that are left unsecured by some careless user, but that won't always be the case. And depending on the situation, we might need to abuse some of the following weaknesses. So for example, misconfigurations on Windows services or scheduled tasks, excessive privileges assigned to the account that were logged in, vulnerable software, missing Windows security patches. And before jumping into those techniques, we need to know what these things are. So first of all, Windows users, they're going from just categorizing them into two general categories. You have the admins, and then you have standard users. And admins have the most privileges, and they can change any system configuration parameter and access any file in the system. But there are sub-levels to admins, right? So you can have an admin for a given branch, and then you can have the admin of the entire company. So the admin for a branch will have lower privileges than the admin for the entire company. The domain admin is another way to say it. Like there's somebody that is administrating the entire domain of the company, which includes probably thousands of endpoints, meaning thousands of computers, and several thousand users, because for each computer there could be multiple users that can access that computer. So there are levels to every game, and this is no different. So admin users can be A, B, C tiered administrators, and then you have the standard users that can access any computer but only perform limited tasks. Typically, these users cannot make permanent or essential changes to the system and are limited to their files. So, for example, if we were to use the bank as an example, because I think it's like the easiest hierarchy to understand. So if you walk into any bank, there's the teller, and then there's the lead teller, and then there's the immediate supervisor to the tellers. Then you have the branch operation manager or the branch service manager, whatever it is, but that's usually the person that's handling the operations of the branch and the compliance elements of the branch. For example, the vault and going and receiving cash and kind of providing overrides to the tellers, things like that. And then you have the branch manager, and then you have bankers that handle the sales side of things. And bankers are typically, they're higher privileges than the tellers, so they can provide overrides to the tellers, but they're usually not higher than the operations manager or the branch manager. So the ops and branch managers end up being the highest levels of privilege inside of the branch itself. And then there's the banker and the supervisor tellers, right? All of those people are standard users. So there's nobody inside of that branch that can create a new user account. There's nobody inside of that branch that can make like really sensitive configurations to any of the computers. If anything, the branch manager might have the permission to reset somebody's password if they get locked out of their computer, and then they can go ahead and get, help them kind of set up a new password. That might be the only thing that they can do so that the IT department isn't constantly resetting people's passwords for them. But apart from that, the branch manager is just a standard user, and that's technically the highest level of privilege inside of that branch. The branch manager can do overrides of millions of dollars and do a lot of crazy things with transactions within the branch with dealing with the clients. But when it comes down to the computer systems, they're very limited. They're just another standard user that exists inside that environment. So any user with admin privileges will be part of the admin group, and then everybody else is in the standard users group. In addition to that, you'll also hear about special built-in accounts or built-in users that are used by the operating system in the context of privilege escalation. So for example, the system or the local system is an account that's used by the operating system to perform internal tasks, and it has full access to all the files and resources available on the host with even higher privileges than admins. So you can have a kind of like a local admin, a lower level admin, and the system will actually have higher level privileges than that person. Then you have the local service, which is the default account that's used to run Windows services with minimum privileges, and it will use anonymous connections over the network. Then you have the network service, which is a default account used to run Windows services with minimum privileges. It will use the computer credentials to authenticate through the network, right? So anonymous connections over the network is local service, and then the network service uses the actual credentials of the computer to authenticate through the network. So it's not anonymous, but it's also not going to be using the user's credentials necessarily. It'll be using the computer's credentials, the system's credentials. These accounts are created and managed by Windows, and you won't be able to use them as any other accounts, or as regular accounts, I should say. And in some situations, still, you may gain their privileges due to exploiting specific services. So, users that can change system configurations are part of which group? So these are our administrators, and we have the system account. Does it have more privileges than the admin user, yay or nay? Or they typed A or nay, so I guess I'll say A. Or is that supposed to be I? Right? Okay, let's talk about harvesting passwords from the usual spots. And for this one, I'm going to start this virtual machine here. All right, let's do the read through first. So the easiest way to gain access to another user is to gather credentials from a compromised machine. These credentials could exist for many reasons, including a careless user leaving them around in plain text files, or even stored by some software like browsers or email clients. We're going to present some known places to look for on a Windows machine. Before going on, I already started the machine itself. I'm going to be using the attack box to try to remote desktop into this thing, or I guess just open the machine itself, because when we go into it, when we actually do show split view, it has two little tabs at the bottom right here for me, and one of them is actually the Windows machine itself, which I think is what's going to be loading on that's the Windows machine. So I will open this up in a full screen mode for us so that we can just get access to it relatively easily without having to use the attack box. The attack box, if we ever need to launch any kind of a payload or create any kind of a payload, it will be useful to create the payload in the attack box and then transfer it to the Windows machine. So that might be what I end up doing later on. But I think for this specific exercise, we can probably just rely on the machine itself. So this is one of the things that I really dislike about the Windows virtual machines. They keep saying that there's a connection error and then you have to reconnect every single time. So there we go. So this is the actual Windows machine, pretty standard. We can see right here we have the very, very basic elements of it. You can actually get the, what is this? I think it's like a Windows 11 or maybe a Windows 10. What do we have over here? Does it tell us? No, it doesn't tell us. Anyways, doesn't matter. So, okay. Let's talk about this piece, the unattended Windows installations. When installing Windows on a large number of hosts, admins may use Windows deployment services, which allows for a single operating system image to be deployed to several hosts throughout the network. This is what happens in enterprise environments. This also helps with the updates of those specific computers. If you want to add anything like a new icon on the desktop of every single user, this is the kind of environment that they do it with. So these kinds of installations are referred to as unattended installations, as they don't require user interaction. These require the use of an admin account to perform the initial setup, which might end up being stored in the machine in the following locations: unattend XML, Windows Panther unattend, Panther unattend, unattend XML, Windows System sysprep, Windows System sysprep, etc. As a part of these files, you might encounter credentials, right? So inside of the files, you might encounter credentials. Then there's the PowerShell history, which is basically the history of commands that have been typed into PowerShell. It stores all of those things inside of a file that keeps a memory of the past commands. It's useful for repeating commands that you've used before. If a user quickly runs a command that includes a password directly as part of the PowerShell command line, it can later be retrieved by using the following command from CMD, not from PowerShell. So if you use type, it basically prints out the contents of this file onto your screen, and the file itself is the console history txt file. Console host history txt file. So when you do this, it actually prints the contents of that console host history onto your terminal. It will only work from CMD. PowerShell won't recognize user profile as an environment variable. To read the file from PowerShell, you would have to replace user profile with the actual, or not the actual, with this specific syntax, which is the environment's user profile. Saved Windows credentials. So Windows allows us to use other users' credentials. This function also gives the option to save these credentials on the system. The command lists these saved credentials with just CMD key and then just list. And you can't see the actual passwords. If you notice any credentials worth trying, you can use them with the run as command and the save cred option. So run as, save cred, and then give it the user name, and then you want to say run something as that user. So we're going to run the user admin with the saved credentials, and what we're going to run is cmd.exe. And so the cmd instance that will be launched from this command will be ran as the admin user. Then you have the IIS configuration. It's the Internet Information Services, and it's the default web server on Windows installation. The configuration of websites on this is stored in a file called web.config and can store passwords for databases or configured authentication mechanisms. Depending on the installed version of IS, we can call it, we can find webconfig in one of the locations. We have inetpub webconfig, then Windows Microsoft Net, yada, 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 webconfig. There is a quick way to find it, right? So you type again and then give it the full path to the configuration file. And then they pipe the output of this into the find string command, and then you're looking for connection string. And then you will pull from that configuration file the connection string and see if you can find any useful information. Then we have retrieving credentials from the software PuTTY, right? It's an SSH client commonly found on Windows systems. Instead of having to specify a connection parameter every single time, users can store sessions where the IP user and other configs can be stored for later use. While PuTTY won't allow users to store SSH passwords, it will store proxy configurations that include clear text authentication credentials. So to retrieve these stored proxy credentials, you can search under the following registry key. So if we do a registry query, and then we pull this specific key, which is the sessions of PuTTY, and then we're looking for proxy inside of it to see what we can get. Simon Tatham is the creator of PuTTY, and his name is part of the path, not the username for which we are retrieving the password. So when you see this right here, this is not the actual user. That's just the creator of PuTTY. The stored proxy username should also be visible after running the command above that we have up here. So we should be able to get the usernames actually in there. And just as PuTTY stores credentials, any software that stores passwords, including browsers, email clients, FTP clients, SSH clients, VNC software, will have methods to recover any passwords that the user has saved. So there is a password for Julia Jones, and it's been left on the PowerShell history. What is the password? So let's have some fun with this. So to retrieve the PowerShell history, we can just use this command right here. Now I'm going to copy this and hope that this actually works. So we're just going to go down here. I can either do the search command right there or the search button that's at the bottom left, or just type click on the Windows button. In either one, when you click on it, you can just start typing. And so I will do PowerShell. Let me see if, there we go. Not PowerShell ISC. I want PowerShell, the app itself. So there we go. Windows PowerShell. We open this up. There it is. And let's see if I can just do Control V here. There it is. So typed, or it pasted the command for me. And now I can just do Enter. And let's see what we get. Okay, I made literally the mistake that they told us not to make, because this is not something that will work in PowerShell. I didn't even pay attention to the instructions that are. So we have to actually run that inside of the CMD, the command prompt. So let's type this in here. Let me see if I can paste that. Does that? Nope, I got to do it again, I think. So let's go. It literally says it right there. It's like, don't do this inside of PowerShell. It won't work. Okay, there you go. Cool. So what do we have? We have the user Julia Jones, and her password is this thing right here. So Control C. What did I copy it? I wonder if Control C worked. So let's see if that copied it. It did. Excellent. A web server is running on the remote host. Find any interesting passwords on the web config file associated with IIS. What is the password of the dbadmin user? So now we want to get the IIS web server. So let's do this piece right here, copy that, and I guess we would also do this in the CMD, I think. So let's paste that here. And okay, I think it worked. So it's pulled some information for us here. And we want the dbadmin password, right? That's what it asked for. So let me see if I can find it by searching through this. It is towards the end right here. It's right this section right there. So we have ID dbadmin, and we have password. I don't think it includes the quote. We need it without the quote, I think. We might need the quote at some point, or maybe the quote is a part of the password, but I think it's not. Okay, there we go. There's a saved password on the Windows credentials. Using CMD key run as, spawn a shell for Mike Katz and retrieve the flag from his desktop. So we're going to do the run as command, which was right here. And so we're going to copy this one, but we're running it as Mike.Katz with a K and a Z. So we're going to paste that here. And did it not copy? Come on, buddy. Why are you doing this to me? Should be copying these things. Copy and then paste it. There we go. So now we're going to change the user to Mike.Katz like that. And cool. It opened it up as Mike Katz. And now it says, where's the flag? I think it said it was on the desktop. Using CMD and retrieve the flag from his desktop. Yeah. So we are currently in Windows System 2. So who am I? Let me see if it'll tell me. I am Mike Katz. Excellent. Print working directory or current working directory or dir, I guess. Oh my God. Okay. Bad thing. I am inside Windows System 32. Let's just do that. How about that? So CLS will clear the screen. And now we want to go into the desktop of Mike Katz. So if I do dir, we can go into users. And if I do dir, we can see there's Mike Katz. So let's go into Mike Katz user. And then we should be able to see a desktop. There we go. And finally, let's do a dir and we see the flag. So type flag.txt and there it is. THM. What is my password is the flag, or I think There we go, right there. Okay, cool. And there it is. Retrieve the saved password stored in the saved putty session under your profile. What is the password for Tom Smith? So we can safely get rid of the My Cats window, and we want the one that is in our profile. So retrieving it from the putty credentials, which is just this whole thing right there. So I'm just going to copy that and go here, paste the command. I don't know why it won't. I think it's like if you don't automatically just paste it, and if you just right click on any random area of it, by right clicking it'll copy that area, and then I right clicked on an empty space, so it copied an empty space. But this is what we got, so press enter here and let's see. Okay, there we go. So we're looking for the what is the username? Tom Smith, right? So proxy username Tom Smith, proxy password is coolpass2021, and that would be it. So let's do that. Nice. Okay, cool. So those were all really quick, right? These are the usual spots that we can retrieve the passwords from. So let's look at other low-hanging fruit. Quick note, just to keep this piece in mind, for the most part, you're probably not going to run into this kind of stuff in a real world situation. Most likely you will find these in the realm of capture the flag exercises rather than actual scenarios that you'll find in real pen testing engagements. But if none of the previously mentioned methods that we just worked or we talked about works, then you can always go back to these things, or you can just kind of do this anyways. Even if it's in a real pen test, you can do it anyways just to see if you can find anything. And if you don't find anything, fine. But at the very least, you left no stone unturned, right? Looking into scheduled tasks, this is something that we also did with Linux. You may see a scheduled task that either lost its binary or it's using a binary that you can modify. So you can do sh tasks, the command, without any kind of options, and then you'll retrieve detailed information about any of these things. And you can use a command like this one. So sh tasks, and then the name of the task, and then get a list, right? So it'll actually pull whatever information about it. For example, it's going to be running it as task user 1. The task that it's going to run is this specific file, and that's the name, and it's going to be running it on this host, for example. So when you do this command just by itself, it'll give you a list of the tasks, and then you can do the full command and get the details about any given task to see what potentially you can modify maybe. You'll get a lot of information about it, but what matters is the task to run parameter, which indicates what gets executed by the scheduled task, and the user run as user, right? Which tells us which user will be used to execute the actual task. If our current user can modify or overwrite the task to run, then we can control what gets executed by the task1 user, resulting in a simple privilege escalation. To check the file permissions on the executable, we can do icacls. ICACLS, and then we give it the path of the actual task, and then it'll say which user, right, which permissions are assigned to it. So the NT authority system and the built-in admin and the built-in users, right? So authority system has IF, admin has IF, and the users also have IF, and F is full access over the task's binary. This means that we can modify the .bat file and insert any payload that we like, and for our convenience they have the netcat64 executable, which is inside of the tools directory. So we can change the bat file to spawn a reverse shell, and you can do that by using echo and then give it the command that you want it to run, which is the netcat64 executable path, and then you say execute cmd.exe, and then you give it your attack box's IP address and the port, and then you take this entire command. So this is what echo does, right? Echo will basically take this entire command right here, and it'll transfer it to this bat file. So anytime that bat file is executed from now on, it'll be running this command. Now, in order for netcat to actually work and connect to this IP address and port, you need to have a netcat listener waiting on this IP address and port. Otherwise, this is going to be useless for you. So just keep that in mind. Oh, there we go. This is what they said. So you can start the listener on the attack machine on the same port. Very good. So the next time the scheduled task run, you should receive the reverse shell with task user 1 privileges. While you probably won't be able to start the task in a real scenario and would have to wait for the scheduled task to trigger, we have provided your user with the permissions to start the task manually to save you time. So you can always just do this and then run the actual task immediately. And then you'll receive the reverse shell on the attack box on the Kali Linux machine. And then it'll show, so you can see right here, this was the original command line. And then right here, after the netcat connection was established, it's now the Windows user. And then if you do the who am I command, it'll say that you are whoever that user is. So go to their desktop to retrieve a flag. Don't forget to input the flag at the end of this task. So I think that's probably the best way to do it, is to just go through these things one by one, retrieve the flags, and then get that done. So if we go, let's just kind of start from the top right here. So if we do SCH tasks on this machine, SCH tasks, it'll show us the long list of tasks that are available here. So let's see what, if the one that they wanted us to modify, which is which one? I think it's the SCH or SCH task.bat. So that might be the one that we would be interested in modifying. So let me go see if I can see the update binary folder, etc., etc. Let's see if we can find that one. Okay, so this might be a little bit tedious. So here's what we're going to do. We're going to run SCH tasks. So I'm going to clear the screen. We're going to run SCH. Let me zoom in on this a little bit more for you as well, so you can kind of see what's going on here. So we will do SCH tasks, and then we're going to pipe that into the find string command. And we're going to see if we can find that SCH tasks bat. Okay, so it doesn't exist. So I think, or it's not, actually it's not tasks. It's the SCH task bat. So I got to remove that S. Okay, it still didn't find it. Okay, so then I think what we can kind of gather here is that maybe this is the actual file itself that we're trying to modify. So let's go and see if it is that. So if I do type and then paste that, let's see what's inside of this. It says who am I, task output, ipconfig, task output, and then it exits. So okay, so that's fine. So I guess that would be the thing that we're going to be modifying. So what we're going to do in this case is we're going to just put this whole thing inside of this, and we just need to make sure that we modify the attack box IP and all of that. So let's now go open the attack box so that we can connect to it, or I need to actually have the listener running. So I will go ahead and open that. Let's minimize that back again. So this should be excellent. So this is the actual attack box. So if you have no idea how to run a netcat listener, it's very, very easy. It already showed us the command. So it's nc, and then you just give it the flags that you want. So lvnp is the one that I basically always do. So I do L for listen mode, V for verbose, N for numerical or non-DNS. You don't want the names to be resolved. Just N could be whatever helps you remember that. And then P is just to give it a port. So the port is going to be port 4444. There we go. That's it. We have our listener. Now to make the modification on the target machine, we need to give this IP address 10.201.118.40. 10.201.118.40 is what this needs to be changed to, this attacker IP. So it would be 10.201.118.40, and that's it. And so we put that inside of this thing right there, and we should be able to just run it manually, because they said that they've given us the permission to be able to run that manually. And in that case, this would be the command right here. And the task name in our case is, I don't know if it's vuln task, because I don't know if that was the one that actually was the task itself. So I already echoed that. So if I go ahead and just look at the contents of this, it now shows us that the contents have been changed to the netcat listener. So that's great. So now we can see if we can find maybe vuln task. Maybe that's the one that they changed, right? So vuln task. it does exist. Okay, good. Okay, cool. So maybe I was looking for the wrong thing over there. So we can now do this command right here to actually just run the full or manually force the connection of that to run. And so this is what our netcat looks like right here. So over here, we're just going to go ahead and paste that, enter, attempted to run the scheduled task, run task, and there you go. Look at that. The connection is established. So cool. So who am I now? I am task user 1. Excellent. I think we're trying to find it on the user's desktop, or not, excuse me, dir. So the task user 1. So cd task user 1, and clear the screen a little bit for me. It's not going to clear the screen. What about that? That's not going to clear the screen. Okay, well, whatever. Let's just go down here. Okay, so we are now looking for what? We're looking for their desktop, and in the desktop, there should be a flag. There we go. So type flag onto my screen here, and there it is. So that's the first one. Oh, when you do Control-C, because it is not a stable connection, it ruined it. So task 1. Nice. And there was actually only one question. So the rest of it is just going to be a quick little read through. So let's read through this one, the always install elevated. And I think we might actually need another exercise for the machine that we're logged in on right now. So I'm not going to bring down that machine yet. So, okay, so always install elevated. The Windows installer files known as MSI are used to install applications on the system. They usually run with the privilege level of the user that starts it. However, these can be configured to run with higher privileges from any user account, even unprivileged ones. This could potentially allow us to generate a malicious MSI file that would run with admin privileges. The always installed elevated method won't work on this room's machine, and it's included as information only. Okay, so this method requires 2 registry values to be set. You can query these from the command line using the commands below. So the registry query command, and then you give it these paths, and the paths themselves are HKCU, the current user, and HKLM, the local machine. And then you go into software policies, Microsoft Windows installer. Okay, so you're looking at this full thing right here for the current user and for the local machine. Okay, so to be able to exploit this, both of them should be set, otherwise exploitation will not be possible. If these are set, you can generate a malicious MSI file using MSF Venom. Yes, we have done videos on MSF Venom inside of Jr.PenTester, so you can actually go back, I think maybe 4 episodes, like 4 or 5 episodes prior to the one that you're watching right now, and you'll be able to find the one for MSF Venom. And so this is the command to actually initialize MSF Venom. Then you give it the payload option, and you choose the payload that you want to create. In this case, we are creating a Windows payload for the x64 architecture, and we're creating a reverse TCP shell. Now, this is a stageless payload, I want to say, because I think when it's shell / reverse TCP, it's a staged payload. So I believe this is a stageless payload. And so then after you do that, you got to give it the attack box IP address as a listening host, the local host, and then you give it the listening port of the attack box. So very similar to what we have here, right? What we had previously here, this was our the listening port, the 4444, and then the listening IP was the attack box IP right there. So if we go over here, we have the local port assigned, and then the format of the payload is going to be MSI, and then you just give it an output name, which is malicious MSI. Obviously, you wouldn't name it malicious in a real case scenario. You would name it, I don't know, configuration, or I don't know, something that sounds normal. That doesn't sound like it's a malicious thing. And so being that what we just created is a reverse shell, you again need to have a listener listening. So you would run Metasploit handler, the Metasploit multi-handler module configured accordingly. And the way that you would do that, just to kind of give you an idea, so you're not just going based on based on just theory. I'm going to launch MSF console just to show you what you need to do to configure the multi-handler. But basically, this command will be run exactly as it is. The only thing that's going to change is the listening host and the listening port. That's the stuff that's going to change to your machine's IP address and then the port that you want to listen to, okay? Once you do that, you need to go into Metasploit, which is what I just did right here, and it's launching for us. You go into Metasploit, and then you use the multi-handler module, and then you configure it to include this payload. I think by default, maybe it actually has that payload, but we may need to just assign it to that. And then when you do, you run the multi-handler, and you would run this payload. So the multi-handler would be your listener, and you run that, make sure that it's actually running. Then this needs to be transferred to the machine that you're running it from, so your target machine basically. So once the file has been created, and I can technically, because the machine itself doesn't have the command, I'm not going to be able to fully execute this, but I'll show you all of the steps that need to take place. So first and foremost, this is what it would look like if we wanted to do it for the creation of the payload. You would do MSF payload, or MSF Venom, excuse me, then it's Windows, and it's going to be on the x64, then it's going to be shell reverse TCP, right, from what I understand. That's what it was. Yeah, x64 shell reverse TCP. And then the L host in this case is going to be the IP address of my machine, which is this thing up here, the 10.201.118.40, and then L port is going to be, let's say, 4444, and then we're going to do the format, which is MSI, and then the output file is going to be whatever. I'll call it venom.msi. There you go. So this will take a few seconds to run, then it'll just create this file for us, okay? Once that's done, there we go, saved as venom MSI. So if I do ls, I should be able to see venom MSI right here. Awesome. So now we can go here, and we have the Metasploit framework itself. It's actually launched. So from here, we want to search for the multi-handler, and it'll give you the exploit itself. So exploit multi-handler, that's the one that we want to use. So you can either do use and then type out that full path that you see right here, or you could just do use and then give it the number of that path, which is 7. Press enter. Now we're inside of the multi-handler. So the thing that you need to always do inside of all of these modules is to look at the options. And now it just says that you want to have the listening host connected to it, which is again our IP address, the 201, etc., etc. So let's do that. So we're going to do set L host, and then you're going to do 10.201.118.40, and that would be the IP address of, yep. Okay, so that's it. And the port is 4444. Now here's the key piece. The payload right now is the generic shell reverse TCP. So we need to change that payload to be this payload right here. Otherwise, they won't work. So when we finally run Venom MSI, it's not going to actually work. So what I'm going to do is I'm going to do set payload, and then I'm going to do the Windows /x64 / shell _ reverse _ TCP. And now when I do show options again, we can see that my payload has actually changed from the generic to that Windows TCP. So great. Now I can do run, and it'll initialize this multi-handler for me. Okay. Once that is running, the next piece that I need to do is I need to transfer this file to the Windows machine that we have. But unfortunately, it's not, that part of it is not going to work. But I'm just going to show you all of the steps that you would take. So to transfer the file, my favorite method is to do a Python 3 HTTP server, and then put it on port, let's say 8888. So now there's a server from this machine, meaning this machine is serving data on port 8888. So anybody who wants to access it, they can. And then we know that port 8888 is currently running on this location. So if you do the IP address :8888 / venom MSI, you would be able to download this file. So then we would go into this section right here, and I believe it's wget is a command. So it's not a command that we can run. So what is the command to download files? Hold on, let's see. Okay, got it. So it's actually curl. The version of that would be curl. So if we go here, so let's just make sure it is curl. So curl, okay, very good. So it is installed, and it just says that you need to, okay, so you do this, you do curl, and then what is the full command? Output file is that, and then the, okay, so great. So the output file in this case will be output. Again, I'll just do venom.msi. And then what I'm downloading is the file from my server, which is that 10.201.118. What's the IP address here? 10.201.118.40 colon 8888, right? And then /venom.msi. And let's see if it actually downloads it. Oh, okay, the download did work. So if we go over here, we can see that there was a query that was made from that machine, and it was a get query, and it downloaded the venom.msi file. So we actually can now do a dir command, and we will see that we have the venom.msi file downloaded. Up until this point, this is exactly what you would do, okay? And then what you would do next is you would run that venom MSI file, okay? It's very similar to running any other file. It's just that it's not gonna work in this case because the pieces that are relied on over here, always installed elevated, it won't work because it's not included on the actual machine, right? On the Windows machine, it won't work. But literally up until this point, this is exactly what you would do. Excuse me, now I'm hiccuping. So this is exactly what you would do. You just need to make sure that these things are installed. And so if they're set. If they're not set, then it's not going to work. So these commands would be the commands that you would run to do the current user and the local machine to see if those Windows installer and all of that stuff is good. And if it is, then you've downloaded your payload, everything's ready to go. You can run this, and then the exercise that we're talking about here would actually work. So you can see that my reverse TCP handler is actually listening, it's running. I have my server that's running. I can just stop this from running because I downloaded the file I needed to. And that's basically it. It's not really a complicated series of things. It's just you got to make sure that you do all of those pieces correctly, and then it will work for you. So that is that for this exercise. And this is it, the MSI execute in quiet mode, and then you would give it the path to the MSI file, and it will work. The reverse shell listener would also be working, etc. All of those things will actually work, and you will get your bind or reverse shell that would be connected to your attack box, and then you can run amok. You can do a bunch of crazy things that you probably shouldn't do, but you can do because you were able to hack into the machine. Okay, cool. So let's move on to abusing service misconfigurations. All right, this one is a little bit longer, so this should be a little bit more fun. Okay, let's talk about Windows services. So Windows services are managed by the Service Control Manager, the SCM, and this is a process in charge of managing the state of services as needed, checking the current status of any given service, and generally providing a way to configure services. Each service on a Windows machine will have an associated executable which will be run by the SCM whenever a service is started. It's important to note that service executables implement special functions to be able to communicate with the SCM, and therefore not any executable can be started as a service successfully. Each service also specifies the user account under which the service will run. To better understand this, we can do the scqc command. And for example, we can look for the app host service. So scqc app host service, and then you get the service name, and then you get the type, start type, error control, binary path, which is very important for us, and then the display name, of course, service start name, right? So the service start, or the I guess the name that can start the service, it will be the local system, and this is the path of the binary, okay? So we can see the associated executable is specified through the binary path name, and the account used to run the service is the service start name. Services have a discretionary access control list, also known as the DACL, which indicates who has permission to start, stop, pause, query the status, query the configuration, or even reconfigure the service, among other privileges. The DACL can be seen from the process hacker that's available on the machine desktop. And so if we go to this guy right here and move this right here, we have that thing. So the process hacker, there we go. This is what we got, right? Cool. So if we go and look for, what are they looking for? The administrator, change my host administrator. What are they looking at? App host service properties. Okay, great. So let's go and try to find the app host service and look at its properties. I think we can actually even search for it right here. Okay, great. So let's zoom in just so you can see what I'm doing here. So if we go here and search for app host, there we go, the SVC host right here. So if I can right click on that and go look at its properties, there it is. And what are they looking at right here? They're looking at the security portion of it. So if we go to seguridad, is there security here? Security is not even here. So am I looking at the right thing? I wonder if I am. I don't think so, because it's this SVC host and then we have services exe. So it doesn't seem to be the one that I need to be looking for. So maybe let's see if there's something else that I should be looking for that I don't see. Or maybe it might not even be on my list because they're just using that as the example in this case. So I think that might be the case. But anyways, we have the process hacker and we saw how we can pull up the information. So all of these services configurations are stored on the registry under the local machine system current control set services. So inside the registry editor, if we actually go to that location, we can see the app host service and all of its various permissions. A sub key exists for every service in the system. Again, we can see the associated executable on the image path value and the account used to start the service on the object name value. If a DACL has been configured for the service, it will be stored in a sub key called security. As you may have guessed, the only admin can modify such registries by default. Then we have insecure permissions on the service executable. If the executable associated with the service has weak permissions that allow an attacker to modify or replace it, the attacker can gain the privileges of the service's account trivially. To understand how this works, we can look at the vulnerability on the splinterware system scheduler. We will query the service using scqc Windows scheduler. And then again, binary path name, display name, and of course the service, which is the SVC user 1. We can see that the service installed by the vulnerable software runs under the SVC user 1 and the executable associated is under this location. We then proceed to check the permissions on the executable by doing the iCackles. And so we can give it the path of this and then it'll tell you everyone can, I guess, modify it. The system has full control. Admin has full control. The user has read and execute, and then all application packages have read execute, and all restricted application packages have also read execute. So as we see, we can see something interesting, right? The everyone group has modified permissions on the service's executable. This means that we can simply override it with any payload of our preference, and the service will execute it with the privileges of the configured user account. So let's generate an exe service payload using MSF Venom and serve it through a Python web server. Oh, that's exactly what we did last time. So we already got some practice with this. So MSF Venom, Windows 64 shell reverse TCP. I mean, I already have one of these, except the format, it was MSI, so it's no longer, I need to just recreate one for exe service, and of course we're going to do it on a new port. And then we have the output name, the rev svc exe. Then we create the Python server. Excellent. We can then pull the payload from PowerShell with the following command. So WOIC, see, wget works on PowerShell. It doesn't work on CMD. On CMD, curl worked. So if I would have ran wget on PowerShell, that should have actually worked. Once the payload is in the Windows server, we can proceed to replace the service executable with the payload. And since we need another user to execute it, we'll want to grant full permissions on it. So you first go into the path of that payload, and then you move this executable to that and then you would, and this I think renames it essentially. It turns it from this exe to exe.bkp, which is a backup, and then we move the executable that we created, that payload that we created, and we put it into this location under this name, right? Because we changed this name to this, so now we can easily just replace it with that. And then you do iCackles, and then you grant the permission of full permission to the everyone group on this specific executable, so we're good. Then we start a reverse listener on our attacker machine, which is right there. And finally, restart the service by doing scstop and then scstart. While in a normal scenario, you would likely have to wait for a service restart, you have been assigned the privileges to restart the service yourself. To save some time, use the following commands from cmd exe command prompt. There you go. And PowerShell has sc as an alias to set the content. Therefore, you need to use the sc.exe in order to control services with PowerShell this way. As a result, you'll get a reverse shell with that privilege, and then go to the desktop to retrieve a flag. So, okay, so the SVC user 1, we need to actually do this exercise in order to be able to get the flag for that question. There are 3 questions in this section, I want to say. So, alrighty, so what do we have here? We're going to do the W service. Is that the one that we're interested in? So let's see if we can actually go find it, the Windows scheduler. So let's go into our CMD right here, and let's see if we can do an scqc and Windows scheduler. Does that exist? It does. There you go. And then there's the W service exe. So I can now change my location. So let me go back here and let's go into the C, and then what is it? Progra, like that. And then the squiggly 2. Okay, great. So now CD into system squiggly 1. There we go. All right. So now we are inside of this location. There's all these things here. And the W service exe, there it is. The W service exe is the one that we want to change. So what we're going to do is we're going to do move W service exe to W service .exe.bkp. That's what it was. And if we do it like that, now we can see the W service exe BKP is there, and the original version is no longer there. So far, we're good in this instance. The permissions I did not check because they just did it, so I don't need to do that. So now we're just going to recreate this payload. So the MSF Venom Windows x64 shell reverse TCP, same attacker IP, just on 4445. And then what we're doing is changing it to an exe-service, and then I'll just name it exactly this. And I like typing out MSF Venom commands because it really, I want to like get it into my fingertips. A lot of people comment and they're like, why don't you just copy paste it? I'm like, you know what? You're absolutely right. I just like typing this out because I want to get really good at knowing how to use this command. And so by doing the copy paste thing, you don't really get to learn it that much. So format is the exe service, and then we have the I should have actually, I don't know if I can change it, but whatever, L host is going to be the 10.201.118.40, and the L port is going to be 4445, and then the output name or the RVC exe, is that what it was? RVC REV SVC exe, that's what it is. REV SVC exe. I think it should work, even though I technically did the format before I did lhost and lport. Yeah, it does work. Great. So there we go. So now we have the REV SVC exe. So now we can do Python 3 and do an HTTP server, and it just does it on port 8000 by default. So that's all good. And in this case, I can stop the multi-handler that was running. I can go back. I'm just going to leave this open, and I'll just open up a new terminal because just in case we need the Metasploit instance, I don't want to reinitiate it and go through that whole thing. So, all right, cool. So now we have that. The port on our listener is going to be the 4445. There we go. There's that. Okay, great. Wait. Oh, not NV, NC. There we go. I completely, because V is right next to C on the keyboard. You know what I'm saying? Okay, so there we go. Now we have a netcat listener. All right, so just to kind of walk you through everything I did, right? I went over here. I created the MSF Venom payload, right? And then I created the Python server. So now this machine is actually serving on port 8000, okay? Then we had on this little area right here, we went into this location, which is the progra and then squiggly 2. And the squiggly on my keyboard is on the left of the number 1 on the top row is that squiggly. So when you hold shift and then you press that button, you'll get the squiggly. And then so progra squiggly 2, system squiggly 1, and then now we're in this location, and we found originally the wservice.exe, and then I used the move command to change it to just this backup file. So now what I can do is I can create a new wservice.exe using this command that they provided us right here, which is the I'm sorry, I need to download this first. I need to first download it, and then we can go ahead and change it. So I'm going to just use curl on the machine because I know that the curl worked. So if I do curl and then what was it? HTTP /10.201.118.40, and then it's on port 8000. And let's zoom in just so you can see this, but you've already seen me do this. On port 8000, and then /rev-svc.exe, and then the output file, I will just do the wservice.exe like that. Cool. So now let's do a dir, and do we have it? We do. We have wservice.exe. Great. So now I need to do iCackles to actually give it the permission of the Windows scheduler. Now all I have to do is I need to just change the permissions of that to grant everyone a full permission. So it is iCackles and then that name and then grant everyone F. So we're going to go right here and we're going to do the iCackles, and then we're going to do the name of the service.exe and then /grant everyone full permissions like that. Great, so I think we're solid. So then what we need to do here is go and stop Windows Scheduler and then start Windows Scheduler. And we should receive our reverse shell connection because it is currently listening. So fingers crossed here. So we're going to do, I forgot already, it's sc stop, sc start. Okay, great. There you go. That's all we got to do. So we're going to do sc stop Windows, if I can type to save my life, Windows scheduler. And it has been stopped. Great. Okay, sc start Windows scheduler. Okay, start. Okay, great. So now look at that. I love it when these things work. Excellent. So who am I now? I am SVC user, baby. Okay, so let's go and get that flag. Can I just do this? Great. Okay, great. So SVC user 1. And then his desktop. And let's just do type flag. There it is. Wonderful. Ladies and gentlemen, we made some progress here. And there is the copy. And let's go and paste that into the first. Where is it? My gosh. Wow, this is a lot of instructions, yo. Okay, there you go. Did it work? It worked. Great. Wow, look at that. I have this, like, I don't know. They keep adding new things to the stuff over here. This is all so cool. Like, it helps you with tracking your progress. I'm very, very excited about that. Okay, so let's go to the unquoted service paths. When we can't directly write into service executables like we just did, there might still be a chance to force a service into running arbitrary executables by using a rather obscure feature. So when working with Windows services, a very particular behavior occurs when the service is configured to point to an unquoted executable. By unquoted, we mean that the path of the associated executable isn't properly quoted to account for spaces on the command. So spaces. So you see these spaces right here, This is what they're talking about here. So the difference between two services. So these are used as examples only and might not be available in the machine. The first service will be a proper quotation. So you see this quote right here. They did the quotation, right? So that the SCM knows that without a doubt that it has to execute the binary file in its entirety because we put it inside quotes, right? So if we do the SCQC VNC server, you see that it is inside of quotes. The path is here because there's a separation here, there's a separation there, okay? That's what we get. So PowerShell has SC as an alias to set content, therefore you need to use SCEXE to control services if you want in a PowerShell prompt. Everything we've been doing is inside of command prompt. If you do SCQC the disk sorter enterprise, then you'll be able to also find everything. And then we can see again that now in this particular case, there is a separation, right? But it's not inside of quotes, okay? So keep that in mind. So when the SCM tries to execute the associated binary, a problem arises. Since there are spaces in the name of disk sorter enterprise, the command becomes ambiguous. And the SCM doesn't know which of the following that you're trying to execute. Are you trying to do the disk exe, the sorter, this thing? Are you trying to do the program disk sorter, which is this thing? Are you trying to do disk sorter enterprise and this piece right here, right? The command, the argument, and then the second argument, right? These are the things that you aren't really accounting for when you see spaces, disk sorter enterprise, right? So the first one is my program's disk. That's basically what it's trying to do. The second argument would be an actual argument to this because it would run this as a command, and the thing that's separated with a space and comes next, this actually is now considered an argument, you see? So it's going to run the disk executable because that's what this basically looks like. And then the command, or the argument to this command would be the sorter. And then the second argument is this thing right here, right? So it's reading this as the initial command, and then it's reading these two portions as arguments because they are separated by spaces, and this whole thing is not inside of quotations, right? It could also be the disk sorter exe that it might think that you're trying to run. And if that's the case, then what it's going to do is that this ends up becoming the first argument, or you could be actually trying to run the full thing with no arguments, right? That's basically how you kind of break that down. So this has to do with how the command prompt parses a command, right? So I pretty much just kind of reviewed all of this for you, so we'll just kind of read through this real quick. So in the first portion, it'll search for programs disk exe. If it exists, the service will run this executable. If the latter does not exist, it will then search for programs disk sorter.exe. If it exists, the server will run that executable. If it does not exist, then it will search for programs disk sorter enterprise bin, etc., etc. And this is expected to succeed and will typically be run in default installations. From this behavior, the program becomes evident if the attacker creates any of those executables that are searched for before the expected service. So for example, since this is the final one that's expected, if we create this or if we create this, then we might be able to win. So they force the service to run an arbitrary executable. While this sounds trivial, most of the service executables will be installed under the program files or program files like this, right? So you see program files is separated by a space, and then there's the program files space x86. which isn't writable by unprivileged users. This prevents any vulnerable service from being exploited. There are exceptions to this rule. Some installers change the permissions on the installed folders, making the services vulnerable. An admin might decide to install these service binaries in a non-default path. If such a path is world writable, the vulnerability can be exploited. In our case, the admin installed the disk sorter binaries under CMyPrograms. By default, this inherits the permissions of the C directory, which allows any user to create files and folders in it. And we can check this using iCackles, and then looking at my programs. And then you can see that the users right here have read, execute, ADWD world. Actually, I am kind of confused about these permissions. So let's see what it says. So it says the built-in users group has AD and WD, allowing the users to create subdirectories and files. So AD would be subdirectories, WD would be files, respectively. The process of creating an exe service payload with MSF Venom and transferring it to the target is the same as before. So we're just going to create another one. Now it's just going to be on port 4446, but same thing, exe service, rev service 2 now, right? And then we're going to do a netcat listener. All of that is going to be the same. Once the payload is in the server, move it to any of the locations where hijacking might occur. In this case, we'll be moving the payload to my program's disk.exe. We will also grant everyone full permission on the file. So we're going to move the executable we just created to my program's disk.exe. That's going to be the new location, and the new file name is disk.exe. So it changes from this to disk.exe. And then we do iCackles, and then we grant everyone full permission. Once the service gets restarted, then the payload should execute. So sc stop disk sorter enterprise, sc start disk sorter enterprise, and then the netcat listener should execute under svc user 2, and then we can go to his desktop, or their desktop, I should say, to retrieve the flag. So let's first go and look for this first command right here, this piece, scqc disk sorter enterprise. That's the thing that I am trying to get more information on, right? That's the one that we're trying to manipulate. So scqc disk, not desk, Jesus, disk sorter enterprise. And there we go. So it's right there, disk sorter enterprise, space with a, or separated by spaces. This whole thing is not inside of a quote. So we are good to create that kind of a payload and take advantage of it, right? So the very first thing would be to go ahead and create this payload. So pretty much very almost identical to everything else we've done, except what we're doing is doing it on 4446, and then we're naming it revservice2.exe. So this would be on this one right here. I'm going to go ahead and close that out. And this connection right here, I also want to just exit that connection. There we go. So that connection's out. And Metasploit is just going to be there. It's all good. So let's go and recreate that payload, which is this thing right here. So I don't need to type this out, even though I can technically. So it's going to be revservice2, and then we're going to go over here and change it to 4446. And that's going to create our payload for us. Once it's done, we're going to do a Python server again real quick. So there we go. So let's list it. And there it is, revservice2. So Python 3, and give me an HTTP server. And there is that. So there we go. We're good to download that. And now we can go into our Windows machine right here. And I'm going to go to just the C location real quick. And then in the C location is where I'm going to do the curl query. And I'm going to download that. What is it? It was 10.201.118. 10.201.118. 40 on port 8000 / revsvc2.exe, and binary output can mess up your terminal. To tell curl to output to terminal anyway, consider doing output. Oh, I see. Did I not do that? Okay, so boom, and then let's do output, and we're going to change it to downloading svc. svc2.exe. Let's do that. Okay, there we go. So, oh, permission denied. Failed to create the file, failed writing, could not resolve host. Maybe it's because I'm like in the C drive. Is that what it is? So let's see, let's do users. And inside of users, who am I? I am THM unprivileged. So let me go into THM unprivileged and let me go into the desktop, not desktops, desktop. And now let's try to see if we can download it one more time. Could not resolve host rev svc2.exe. Why? What is going on? Why can't you find it? 201.118.40 on port 8000 rev svc2.exe. Isn't that the name of the file? It downloaded it 3 times. What are you talking about? It literally downloaded it 3 times. How is it not working? That's so annoying. So it should be here. It's there. I don't understand why it's saying the error message is literally right there. It's literally right there. Okay, great. So that worked. That was annoying. Okay, but whatever. All right, cool. So now we're going to move that to the programs, my programs, and then we're going to name it disk.exe because that's the path. So remember, right? When we went over here and we looked at the permissions of this, you can see that there's my programs disk sorter. So we're going to change it to my programs disk.exe. That's where we're going to transfer this thing to. So we're going to do a simple move command and we're going to say move it from users THM unprivileged desktop and rev svc2.exe, and we're going to take it to the my programs disk, not dot, excuse me, disk.exe, like that. One file has been moved. Excellent. So we're good. Now we need to do the iCackle, I want to say. Let me just make sure that I am actually doing that right. Yes, iCackle, and then we want to grant everyone access. So first I'm going to go into the C drive real quick, and then I'm going to grant everyone access, and then stop disk sorter enterprise, start disk sorter enterprise, and let's make sure that we have our netcat listener running here. So NC and LVNP on port 4446, I want to say, right? Because that's the location that we saved this on. Yeah, 4446, great. So now we can go over here and let's do the iCackles, or actually let's go into the C drive real quick. And then we're going to do iCackles. We're going to give it the path, which is the C my programs disk.exe. We're going to grant everyone full permission. And excellent. Cool. So we are good. So now we're going to do sc stop the disk sorter enterprise. And there it is. And we're going to do sc start disk sorter enterprise. Specifies disk sort. I see. sc start disk sorter enterprise. There we go. Dude, if I could only tell you, and there it is, nice. Honestly, if I could tell you how many times I have made a spelling error and the spelling error was the reason why things didn't work, it would baffle your mind, honestly. Users and svc user 2 is where we're going to, and I should have just gone into his desktop and get the flag. And there we go, quotes, baby. That is the name of the game in this particular situation. And voila. And the flag on the admin desktop. That's the last one that we want to work on. So this one is going to be the insecure, the insecure service permissions. You might still have a slight chance of taking advantage of a service if the service's executable DACL is well configured and the service's binary path is rightly quoted. Should the service DACL, not the service executable DACL, the service DACL, should the service DACL allow you to modify the configuration of a service, you'll be able to reconfigure the service. This will allow you to point to any executable you need and run it without an account that you prefer, including the system itself. To check for a service DACL from a command line, you can use the access CHK, the access check, from the sysinternals suite. For your convenience, a copy or for our convenience, I guess, in this exercise. A copy is available at C Tools, but you can always just download sysinternals. The command to check for the THM service is DACL. The DACL is access check 64 exe, and then QLC, and then THM service, okay? And it'll show you the access types, right? So you have the NT authority system, and then service query stats, configuration, interrogate, enumerate, pause, continue, or start, stop, and user defined control, read control, and then the built-in users have all access, right? Or I think service all access. So let's see. Here we can see that the built-in users group has the service all access permission, which means that any user can reconfigure the service. Before changing it, let's build another exe service reverse shell. So very similar, now just 4447, and then we're going to call it rev service 3 here. We'll then transfer it using the Python executable, store it in this location. Feel free to use wget to transfer it and move it into the desired location. Remember to grant permissions to everyone. So everything we've done so far, and this is the permission granting, iCackles, etc., grant everyone permission. To change the service associated executable and account, we can use the following command. So scconfig thm service, the binary path, and it's going to be the new executable that we created, and the object is the local system, okay? This command is the new one that we haven't really used so far. Notice that we can use any account to run the service. We chose local system as it's the highest privilege account available to trigger the payload. Everything else is the same. So stop service, start service, make sure the netcat listener is running, and then you'll have it. And then now you'll have access to the system. And then you can go to the admin's desktop to retrieve the admin flag. So this one is, I mean, the instructions at least are fairly short and sweet. So we can do first let's go to tools and access check just to kind of run the command and practice it a little bit. So it is inside of the CD, or inside of this, do we have tools? We do, yes, CD tools. And then in the tools, there's access check. So let's go into CD access check. And then inside of this, we should have the executable. I think it's the 64, it's the 64 run that they ran. Yeah, access 64. Okay, great. So let's do the access check 64. Check 64.exe. And then we want the THM or QLC. I need to do dash QLC THM service. And ooh, look at that. Yes, I agree. And it gives me all of the permissions and everything for THM service. Wow, look at that. That was cool. That actually asks for permission to allow it to check it. And so THM service is now, this is the allow ACE type. So NT authority system itself. What else do we have? Allow ACE type built-in administrators, all access, and etc., etc. So I think it's the built-in users, all access. This is the piece right here that they were trying to get us to really pay attention to. So, okay, so all of that is good. That means that we actually have permission to run those things. So now we're going to go create or recreate that same exact MSF Venom payload, and we're going to put it on port 4447. We're going to name it Rev Service 3, and then we're going to have the netcat listener, and then we're going to transfer it to this location and do iCackles to give the permission. So let's do all of those things to make sure that we are good in this regard. So over here, we're going to get out of this thing, and over here, we're going to go create our payload, and I'm just going to do the MSF Venom repetition. So Rev Service 3 right here, it's going to be on port 4447. That's going to run, and we should be solid. And then right here, we're going to do the netcat listener, and we're going to do it on 4447. And that's listening. Great. On this side, we're going to check for the file. There it is. So we're going to do the Python HTTP server, Python 3, my bad, Python 3 HTTP server. Okay, there we go. So there's Python 3. So we're downloading Rev Service 3 onto our Windows machine. And we don't want to do it from this location. We want to do it from the CD users THM, or what's the name of the user again? the name of the user is the THM unprivileged. So we're going to go to the THM unprivileged user. Then we're going to do the curl command. And it's going to be 10.201.118.40. Is that right? Did I remember it? That would be cool if I did. 10.201.118.40. Nice. And then port 8000. And then rev service 3.exe. And binary output. Okay, again, we need to just make sure we give it an output file. So rev service 3.exe. Okay, there we go. And do I have the file? I do have the file. Excellent. So now we can do the iCackles. So iCackles and the rev service 3.exe. And we're going to grant everyone full permissions. There we go. All right. So hopefully, I don't know if you can see this like super close or if I need to like super zoom in on it, but I think you can also zoom in on the actual YouTube video with, if you're watching it on your phone, you can kind of zoom in with your fingers, or you can just go full screen mode on your web browser on your computer, and you should be able to watch that. Okay, so cool. So all of this so far is pretty straightforward, right? We've gone all the way over here. We granted everybody the permission. And so now we need to do the sc config of the THM service and the binary path of it and the local system, etc. I am going to just copy this one just to make life a little bit easier here. And we're going to just copy and paste that over there and do an enter. And there we go. The configuration has been successful. So sc config THM service binary path is the location of this thing that's right here already. And then from there, we're just giving it the local system permission. So we're good. So what's the next? sc stop THM service, start THM service, and we should have our admin connection on this listener right here. So let's see here. sc stop THM service. Okay, sc stop THM service. Why? The service has not been started. I see. So sc start THM am I misspelling it? Is it like lowercase, uppercase? Is any of this? No, it is uppercase. Okay. So THM service. Okay, so sc start THM service. Okay, cool. Now it's running. Okay, so do we have it? We do have it. Look at that. There is the connection. So who am I here? I am the system. Excellent. So let's now go into the users. And inside of our users, there's the administrator. Nice, buddy. Excellent. Let's go into the desktop. Let's type the flag. And there is the flag for the admin. I hope you were able to keep up with what I did. I tried to do it relatively slowly, but hopefully you were able to keep up. If not, you can always just kind of rewind this and play it a little bit slower, or pause the video, whatever it is, to be able to pull it off. But I think you should be fine. I think like you have a decent enough understanding and to be able to pull this off. So now we can actually move on to our next virtual machine. So I can go ahead and terminate this one, and I can close this window right there. I'll leave the attack box open, but one big thing, so just so you don't have any issues if you're doing this, you see how at the bottom now it says I have 9 minutes left. This will definitely crash in the middle, so I'm going to extend the timer of that to make sure I don't run out of time. And then now this is also like super zoomed in on this, so we need to go ahead and fix this by clicking full screen, and there we go. Great. All right, so let's go ahead and start this new machine and get the rest of these exercises done. The first set of privileges that we're going to try to abuse are the Windows privileges. So privileges, if you don't already know by now, are the rights or permissions that an account has to perform specific system-related tasks. They can be as simple as the privilege to shut down the machine, up to privileges to bypass some of the DACL-based access controls. So to see what you can do, you can just do whoami/priv, and a complete list of the available privileges on Windows systems is available for this thing. But or through this link right here, but the complete list of what your user can do will be printed onto the screen based on that command right there. So the full list of privileges is available through, I think it's a Microsoft documentation. It's called privilege constants, or the authorization. This is on this specific path right here on the learn.microsoft.com, and then this path right here. So if you want, you can just go to that, or you could just Google Microsoft privileges, and then just make sure that you actually use the learn.microsoft.com link itself, because they update it in real time. And so any changes that are made when you're trying to learn anything about Microsoft, use the Microsoft website, Learn website, just because those things are updated in real time, and any changes that are made are happening on there first, and then all the individual blogs and everything else, they update it after Microsoft updates their website, obviously. So from an attacker standpoint, the only privileges that allow us to escalate in the system are the ones that we're most interested in. So you can find a comprehensive list of the exploitable privileges on the priv2admin GitHub project. So this is now something that will not be available on Microsoft, because Microsoft doesn't want you to have access to the exploitable privileges. So these are the things. So for example, SeAssignPrimaryToken, SeAudit, SeBackup, change, notify, create, global, etc., etc. And I think there's one that we're most interested in. It's not user impersonate, it's SeImpersonate. I believe that's the one that we might be most interested in this particular case. So let's go through the rest of them. So SeBackup and SeRestore are the ones that allow users to read and write to any file in the system, ignoring any DACL in place. The idea behind this privilege is to allow certain users to perform backups from a system without requiring full admin privileges. Having this power, an attacker can trivially escalate privileges on the system by using many techniques. The one that we're going to look at consists of copying the SAM and system registry hives to extract the local admin password. In this instance, we don't actually have a virtual machine that will be displayed. We have to actually do remote desktop into the credential. So the account that we're going to log into is part of the backup operators group, which by default is granted the SeBackup and restore privileges. We'll need to open a command prompt using the open as admin option. To use these privileges, we'll be asked to input the password again and elevate the console. So when you search for the command prompt, when you normally click on it, it doesn't run it as admin. You have to right click it and then run it as admin. Once inside the command prompt, we can check the privileges by just doing the whoamipriv, and it'll show us the list of the privileges that we have. So for example, change notify privilege is enabled. All the other ones here are disabled. To back up the SAM and system hashes, we can use the following commands: reg save, then the local machine system, and then users backup system hive, then reg save local machine SAM, user backup SAM hive. This will create a couple of files with the registry hive's content, and we can now copy these files to the attacker machine using server message block or any other available method. For SMB, we can use the impackets smbserver.py to start a simple SMB server with a network share in the current directory of the attack box. So you can create inside of the attack box, this is what we're going to end up doing. We're going to create a directory called share. Then we're going to use the Python 3 or the Python script called SMB server that'll be available in here. Then we're just going to run the rest of this literally. And we have to provide the username as well as the password for this thing that we have right here, right? So there we go. That's the username and password exactly. Okay, great. So we're going to use that username and password, and then we're going to create the share so that we can create a share named public that will be inside of this folder, pointing to the share directory, which requires the username and password for the current session. After this, we can use the copy command in our Windows machine to transfer both of the files into the attack box. So once you actually have the share folder, we can go ahead and transfer this, right? Transfer this to the IP address of the machine, public, transfer that to the IP address of the machine, public, okay? Once you are there, right, the IMP packet the imp packet, excuse me, has another Python script, which is the secrets dump Python script. And then you will get the SAM hive and system hive, and then you will get just dump that into the local location or from the local. And so you'll be able to get the admin hash, the guest hash. We can finally use the admin hash to perform a pass the hash attack and gain access to the target machine with system privileges. And so this would be done with ps-exec Python, provide the hash of the admin. There we go, that full thing. And then it's going to be on the administrator at the IP address of the new machine that was assigned to us, the new Windows machine that was assigned to us. And then ideally, by the end of it, we should actually have the command line for the system. So I wonder if this is going to ask us for a flag on that one. There's a lot of content. Look at this. This is going to be a monster of a section right here. Wow. Get the flag on the admin's desktop. Use any of the 3 methods discussed to gain the admin desktop and collect the flag. Don't forget to input the flag at the end of this task. So what do we have? We have this is 1, and then we have, this would be 2, and then we have the one that I just did, so this would be 3. So let's try this one. I'm going to try all of them, just so we can try to get some kind of success through everything that we've done. But we're going to try with this first one, with the hives that we're going to download for our system here, and then transfer to the attack box, and then use those in-packet scripts. So the first thing, it seems like I don't need anything with Metasploit, so I'm just going to exit Metasploit. And first things first, we need to create a remote desktop session here. So I'm going to do the xFreeRDP as my tool of choice. It's fairly straightforward, and I want to try this scale 100 to see if I can actually get like a full screen here. So if I do /scale 100, I think, right, that should be able to get me, and they have 100%, so we'll do the % sign at the end of that as well. The V is going to be the virtual machine's IP address that was assigned to us, which is this thing right here. So that's going to be the V. And then we're going to do a /U, that's going to be our user, and then /P, that's going to be the password for that user. So we have this THM backup, and then copy master 555, capital C, capital M. So THM backup, and then that /P, copy master 555. Press enter, and okay, great. We do trust the certificate, and it did not do it in 100%. So let me see if I can even change this. I don't think I can. So I think it's basically, it kind of just leaves it the way that it is right here. So what we want to do is we want to open up the command prompt as an admin, first things first. So we're going to search for CMD, and we're going to right click on it, run it as an admin, and then it'll have this for us. And then we need to give it the password one more time. And there we go. So now we have a command prompt as an admin. Excellent. So the next thing that we want to do, I mean, we already have the privileges, but I guess I'll just run the privileges command. Why not? Let's do like every step of it. So who am I /priv, and it'll say that, you know, all of these things pretty much are disabled, with the notify privilege, the only one being enabled. Okay. So the next thing we're going to do is the reg save commands themselves. And we're going to save the HKLM system and HKLM SAM, and we're going to put them in the users backup system and SAM hives. So it will be the reg save, right? So let's do that. We're going to do reg save HKLM system, and then C users THM, whoops, golly, come on, reg save HKLM system C users. This is where you see how I keep doing this. C users THM backup, and then we're gonna do system.hive. Did that work? Okay, it looked like it worked. So HKLM SAM, and then same thing, users THM backup SAM.hive. Okay, are these actual commands? Reg save, great. reg save. Great. Okay, cool. I learned how to type. My goodness. Okay, so now inside of this, it seems like to start this, we can use this thing inside of just a normal, the basic location. So I just want to make sure that I do it inside of the appropriate location. And they have it, I think, in just the root user's desktop, which would be where we are right here. We are inside of the root desktop. So from here, we're going to do a directory called share. And once we've created the directory, we need to run this whole command right here to actually create that share, the public share. And let's do that. Let's see if that works. So basic same command, configuration parsed. Okay, great. Let's see if this actually works, because this would be great if it worked. Okay, so this is kind of sitting in idle. I wonder if we have to wait for this to finish or if it's just going to sit right there, and while this is running, I guess the share would be working. So we can move on to the next series of commands, which is basically the copy command from the command prompt and transfer these SAM and system hive files to the attacker or attack box IP address /public. So it will be right here basically. So let me move this to the side just so I can kind of see that IP address. But it's basically going here and just doing a copy and giving it the location of the file, right? So it's the user's THM backup and then giving it that system hive. Let's do that first one, system.hive. And then we're going to send it to, the way that they have it is // attacker IP. So // 10.201.118.40, right? Like that. And then they did the /public like that. So I will do /, where is it? Public. Not that. That's not /, that one. Public. Oh, there you go. So now we got some activity over here. Okay, so that it worked. So one file copied. Great. So now I can do the same exact thing, but now I'm going to do, instead of system hive, I'm going to do SAM hive. And there we go. We got another one that's been, okay, great. So now if I go ahead and look at the public location, and what is all this going on? There's a lot of stuff going on. Oh, because this is the X-free RDP. Okay, so this is this thing right here. So with this, we're not going to move, because if I close that, my remote desktop is going to close. Okay, great. So now we can open this up, and let's see if inside of our share folder. So if I go to the, where is it? Do I have a share folder? Yeah, share. There we go. Inside of this, there's the SAM and system hives. Excellent. Okay, cool. So that worked. Okay, so now we can run this command using the to retrieve the password hashes, and it would be while running it inside of the actual, okay, so it needs to be inside of the share folder. That's what it looks like. So we're going to copy that, go over here inside of our share folder, paste this to get the system and SAM hive, and let's see if this actually, there it is. So now there's the admin's hash. So now I can copy this whole thing so that we can, actually I need to probably do it in like 2 different copies, because it gives the admin hash. There we go, right? 13, great. So now they're going to use this script right here and use that full hash without the last 3 colons. And then it's going to be admin at the IP address, which is this thing right here. So I don't know, is this the actual full hash file? No, it's different hashes. Okay, great. Okay, no worries. So let's go ahead and do this piece. We're going to copy this whole shebang, and maybe not like that. I think I'm going to do it like this. I'm going to go over here. I'm going to get a text editor on my screen real quick, and I want to be able to modify it here. So I'm going to paste it here, and I need to replace this with the new hash, and then the rest of it I'm just going to keep the same. So I'm going to go over here, and I'm going to grab this whole chunk, and we're going to go ahead and replace this chunk right here. Right? Did that work? Yeah, it did. Okay, great. So there it is. So we replaced yep, that's the exact same hash that was copied. Great. So now we can take this whole command and go over here and run that command with the admin hash that I just pasted, and it's going to be administrator at 10.201.2192, which is the IP address of the machine. Okay, great. Here we go. Press enter, and let's see if it works. I wonder if I was supposed to do anything else. I may have missed something else, but it says no. Okay, there we go, and we ran this, and then requesting, etc., etc. No, so I'm not supposed to do anything else. It's supposed to just give me access to the system. And so what do we get? We got an error connection, no route to host. Okay, so let's see if I missed anything here. Okay, so the reason why it was not working was because the virtual machine, the target machine, the Windows machine that we have in this task, crashed on me, and I was having a connection issue. And there's another element to this that I just want to make sure you also get. The command that we run at the bottom right here is missing the capitalized A in administrator. So make sure that you just have a capitalized A in that full command, and then we get the connection right here using that final script, or the the Python psexec script right here. Same hash value. It copied the entire thing from the dump that we did right in the previous one, which was and actually right here, it's still in the same window. So when we ran the first secrets dump Python, and we got this administrator hash value, we copied that whole thing, just minus the last 3 colons. You do want to include the colon in the middle as well. So you take that whole thing, the administrator user is capitalized, and then that's pretty much it. You combine it with the psexec command, and everything else will run. So this is the new IP address that was assigned when I restarted the machine. I also restarted the attack box just to make sure that I have brand new sessions and my connections are not going to be an issue. And everything up until this point you already have in the recording. So I basically just paused the recording, restarted all the machines, and I went through the whole process. I created the share folder again. I copied the SAM and system hives that I recreated, and I copied them into the shared folder and ran it. And now we actually have this system, this Windows connection as the admin of an NT authority system. So we should actually be able to get the admin user's flag. So if I go into the administrator folder, there we go. Okay, cool. So we got this. Now we can also go into the desktop, and there should be a flag here. Yeah. So type flag.txt. So there we go. We got the flag for this, and we can essentially use any of these exercises to retrieve the flag. I just wanted to get it at least once so we can get the answer, but I am going to continue with the rest of these exercises so we can actually get all of them. And that way you'll have multiple ways to essentially do the same exact thing. So the very first one that we did was for the SeBackup and SeRestore section. So now we can move on to the next one, which is for SeTakeOwnership. The SeTakeOwnership privilege allows a user to take ownership of any object on the system, including files and registry keys, opening up many possibilities for an attacker to elevate privileges, as we could, for example, search for a service running as system and take ownership of the service's executable. For this task, we'll be taking a different route. So we're going to log into, I see, so there's a new one. So I'm just going to go ahead and close this thing out, and we will do the new connection with the new username and password. So THM take ownership, the world is mine 2022. So let's go and get the IP address real quick. And here we go. So xfree RDP, V is going to be the IP address. The U is going to be THM take ownership, and the password is going to be the world is mine, right? The world is mine 2022, something like that. So THM take ownership, capital T, capital O, the world is mine 2022. Oh my God, the world, I keep misspelling, is mine 2022. Cool, there we go, and there it is. So great. So now we have our Windows instance. Great. Okay, so Run the command prompt as an administrator, look at the privileges, and this is what it's going to be. When I ran it last time, it was the same exact thing anyway, so I'm going to skip this particular step. But you always want to just look at the privileges of the user that you're signed in as. And in this case, we have the change notify privilege that's enabled, and then we have take ownership privilege. It's disabled, and then we have the increase working set privilege disabled. Okay, these are the privileges that we actually do have. They've just been either enabled or disabled. So we'll abuse the utilman exe to escalate privileges at this time. Utilman is a built-in Windows application used to provide ease of access options during the lock screen. So when you actually lock your computer, on the bottom right there's this button that turns off the computer, and then there's a button right next to it which is like this. It looks like kind of like a clock or a compass, I want to say. So it's run with system privileges, and will effectively gain system privileges if we replace the original binary for any payload that we like, as we can take ownership of any file. So to replace utilman, we'll start by taking ownership of it with the following command. So you can take own of the utilman with the following command. So I'm going to go and open up my terminal here, the CMD terminal, as an admin user. So we're going to run it as an admin, and the world, oh my god, I keep misspelling, bro. The world is mine 2022. There we go. Great. So, and then from here, once we have this thing right here, we're going to paste this command right there, which I don't have. So let's go and copy it again right here. Go here, paste it, take ownership. So success. The file or folder, etc., now is owned by THM take ownership. Fantastic. So that's done. So now, being the owner of a file doesn't necessarily mean that you have privileges over it, but being the owner, you can assign yourself any privileges you need. To give yourself full permissions over this, you can do the iCackle on that thing and then grant THM take ownership the full access. So I'm just going to copy this in the interest of time, but I always encourage typing this out. Okay, so iCackles, and then you put the path of the executable, and then you give yourself grant take ownership, which is the user. It can also be everyone, right? That could be one of the things that would also do the same exact thing that this does. And then give yourself full permission, press enter, and there we go. Great, so we're good with that. After this, we will replace the utilman executable with a copy of the CMD exe. So copy CMD exe to utilman executable. So we're gonna go ahead and do that piece. So come right here, paste that. There we go. Overwrite utilman, yes. And there we go. So to trigger it, we will now lock our screen from the start button like that. And then finally proceed to click on the ease of access button, which will run utilman with system privileges. Since we replaced it with a CMD copy, we'll get a command prompt with system privileges. So let's go here and let's just go lock it. So we're going to click on the Windows icon at the bottom. We're going to click on this button, not disconnect. Where is it? It's the user button. We're going to click on the user button right here, just to give you this one. It's this little icon right here. We're going to click on that. We're going to lock the screen. Now we're here, and we're going to go down here, and we're going to click on that button. And look at that. We have a terminal. This one was super easy. So who am I? I am the authority system. So if I go to the users, administrator, and desktop, there it is. And if I look for the flag, there's this. So same thing, we just got the same flag basically. So that was really easy. That one was very, very straightforward. And for this one, I don't think we have a username and password. I think we're just following the instructions on the same account. So let's go ahead and read through the SeImpersonate, SeAssignPrimaryToken privileges. SeImpersonate and assign primary privileges allow a process to impersonate other users and act on their behalf. Impersonation usually consists of being able to spawn a process or thread under the security context of another user. And it's easily understood when you think about how an FTP server works. The FTP server must restrict users to only access the files that they should be allowed to see. So let's assume that we have an FTP service running with the user FTP. Without impersonation, if user Ann logs into the FTP server and tries to access her files, the FTP service will try to access them with its access token rather than Ann's. So this is Ann. I don't know if you can see this. Let me check to see. I think you can't see it. You should be able to see it. But this is too much, so let's do this. So this should be fine. I'll zoom in a little bit more. So this is Ann. Ann authenticates herself with Ann's token, uses the FTP service. The user FTP is belonging to the FTP service. The FTP user will go ahead and use its token, the FTP token, to retrieve Ann's files. And then from here, the permissions are allow Ann to do it, allow the FTP user to do it, deny everybody else, right? And then it'll send the files back. So she authenticates herself, requests the access to her files. The FTP user uses the FTP token and goes and retrieves her files. There are several reasons why using the FTP token is not the best idea. For the files to be served correctly, they would need to be accessible to the FTP user. In the example above, the FTP service would be able to access Ann's files, but not Bill's files, as the DACL in Bill's files doesn't allow the user FTP. This adds complexity, as we must manually configure specific permissions for each served file or directory. For the operating system, all files are accessed by the FTP, independent of which user is currently logged in to the FTP service. This makes it impossible to delegate the authorization to the operating system. Therefore, the FTP service must implement the authorization, So it makes it impossible to delegate the authorization to the OS. Therefore, the FTP service must implement the delegation of that authorization. So if the FTP service were compromised at some point, the attacker would immediately gain access to all of the folders to which the FTP user has access. If, on the other hand, the FTP service user has the SeImpersonate or SeAssignPrimaryToken privilege, all of this is simplified, as the FTP service can temporarily grab the access token of the user logging in and use it to perform any tasks on their behalf. Okay, that makes sense. Okay, so it's basically, in this case, right, Ann uses her token to authenticate herself and to request access to her files. The FTP service has to use its own token to be able to access the files right here, right? The FTP token, if we pay attention to it on the side right here, the FTP token is allowed to access Ann's files, Jude's files, but not Bill's files, right? So only Bill is allowed to access his own files. So this makes it an issue if Bill is trying to authenticate and the FTP service does not have SeImpersonate or assign, right? If it does not have those privileges, then it can't impersonate Bill, therefore it can't access Bill's files, which means that Bill won't be able to get access to his files. Now, in this example, Ann authenticates with her token, requests access, and the FTP service is now using Ann's token to try to retrieve her files. And in this particular case, the FTP service could now use Jude's token. It could also use Bill's token because the impersonate or assign primary token is set. So the FTP service can actually use other users' tokens. So if the user Ann logs into FTP service and given that the FTP user has impersonation privileges, it can borrow Ann's access token and use it to access her files. This way, the files don't need to provide access to user FTP in any way, and the operating system handles authorization. Since the FTP service is impersonating Ann, it won't be able to access Jude's or Bill's files during that session, in the session that the FTP service is using Ann's token. As attackers, if we manage to take control of a process with SeImpersonate or SeAssignPrimaryToken privileges, we can impersonate any user connecting and authenticating to that process. In Windows systems, you will find that the local service and network service accounts already have such privileges. Since these accounts are used to spawn services using restricted accounts, it makes sense to allow them to impersonate connecting users if the service needs it. Internet Information Services, IIS, will also create a similar default account called is app pool or default app pool for web applications. To elevate privileges using these accounts, an attacker needs the following. Number one, to spawn a process so that users can connect and authenticate to it for impersonation to occur. Number two, find a way to force privileged users to connect and authenticate to the spawned malicious process. So spawn a process that allows users that can, spawn a process so that users can connect and authenticate, and then find a way to force the privileged users to connect and authenticate to that spawned malicious process. We will use rogue WinRM to accomplish both of these conditions. So we'll assume that we've already compromised the website running on it, and we have planted a web shell on the following address, which is this IP address. And we can use the web shell to check for the assigned privileges of the compromised account. So if we go to our browser, basically, we can do whoami/privileges. That's a command that you're running inside of the browser, and it will actually give you the results of that, right? So that's basically what you're doing. To use rogue WinRM, we need to first upload the exploit to the target machine. For the convenience, it's been installed for us inside of the tools folder. The rogue WinRM exploit is possible because whenever a user, including unprivileged users, starts the bits service in Windows, it automatically creates a connection to port 5985 using system privileges. 5985 is typically used for WinRM, which is simply a port that exposes a PowerShell console to be used remotely through the network. Think of it like SSH, but using PowerShell. If for some reason the WinRM service isn't running on the victim server, an attacker can start a fake WinRM service on 5985 and catch the authentication attempt made by the bit service when starting. If the attacker has SeImpersonate privileges, he can execute any command on behalf of the connecting user, which is the system. So before running the exploit, we'll start a netcat listener, and then we will run the tools rogue WinRM exe, etc., etc., etc. We're going to run it inside of the web browser as the command right here. And so in this case, WinRM exe is going to execute netcat, and then it's going to execute the command exe using the attacker IP address, which we have to provide to it on port 4442. As long as we have a listener on port 4442, we should have that connection listening for and then we should get that reverse shell connected to our terminal. It can take up to 2 minutes to work, so your browser may appear as unresponsive, but this happens if you run the exploit multiple times as it waits for the bit service to stop before starting again. The bit service will stop automatically after 2 minutes. The P parameter specifies the executable to be run, which in this case is the NC64. The A parameter is used to pass arguments, which we want NC64 to establish a reverse shell on our attacker machine. And the arguments will be what? Execute the cmd.exe, do it on this IP address on that port. If we set it up correctly, we should have the reverse shell. So fairly straightforward. So the big thing that I really need to do to actually just make this work, this was like a lot of like reading to explain the behind the scenes of it. But in order to actually make this exercise work, we just need to go to this IP address in our browser. So let's just do that real quick. I will shrink my terminal here, and this, the world is mine 2022. There we go. And we're just going to open up Internet Explorer, which is a super outdated browser because Microsoft now uses Edge. Ask me later. I don't want to do any of this. I just want to go to this thing, the IP address. Nope. Where's the IP address? I want to go here. So let's do this. Take me there and show me that form. I really want that to work. I hope it works. Excellent. So there we go. So if we run net user, it should give me, yes, I want you to allow. Okay, great. So there you go. It's actually working perfect. So now on this machine, on our machine right here, we're going to close out our connection with that. We are going to go to our root folder here, and then we're going to do netcat and in listen mode, and we're going to do 4443. That's the port that they use, so I'm just going to keep using, or 4442, my bad. Ah, gosh. Okay, so netcat lvnp 4442 is what they did. This really doesn't matter as long as you just make sure that this port is open and you can listen on it. And from there, as long as it matches this IP address right here. So I'm going to take this, copy that. I'm going to go into our little text editor so I could easily modify it because it's hard to do it on the terminal. The attack box is 10.201.40.120. So 10.201.40.120. And we're listening on port 4442. So we're just going to copy that bad boy now. And we're going to go over here and here. Paste it. Come on. Delete that. Paste the command. Run. And we want to watch this thing right here. So there we go. Just like that. It didn't take up to 2 minutes. It was almost instant. So maybe like 5 seconds maximum. And so who am I? I am the authority system, and I can just go to the user's administrator desktop. Whoops. CD to the desktop. And inside of the desktop, what's going on? There we go. CD to the desktop, and there's the flag, and literally you just type flag, and that's it. So there we go. We pulled it off with all 3 of the exercises, and we were able to get the same exact results. I think the easiest one was obviously the one with this thing right here that we did, right, where we got, what is it, inside of the shortcut for the util man. So the ease of access button. This was the easiest one. It took maybe a few minutes to do it. I think the most complicated one was the one where we had to create a shared folder and do all these different Python ones. But for the most part, we, all of them, not really for the most part, in its entirety, they all got us the same results. We were all able to get the remote shell. We were able to get the flag as the admin. So it all worked. So very good. I'm very happy that we were able to pull all of that off. And the main reason, as I already mentioned, the main reason why this first portion didn't work the first time around was because my attack box and my virtual machine had timed out. So I needed to click terminate. I needed to restart the virtual machine that was in this task right here. And then I also terminated my attack box because I think that was part of the connection error as well. And I restarted that. And then I just redid the entire exercise and picked up the recording, and you saw the rest of it. So the rest is history, as they say. So now we can move on to this one, which is abusing vulnerable software, which is our last one. And then we have tools of the trade, which is just going to be some basic exercises that we have just to kind of get ourselves some extra tools to help us. And that's it. We'll wrap it up. So we're pretty close to being done. This was not that bad. I was prepared to go through the worst of it, honestly, when I'm telling you that, like, this was, because of what happened with the Linux privilege escalation video, I was like, dude, this is probably going to take me like 5 hours to do because Windows tends to be more complicated and blah, 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 blah. And I still don't want to get ahead of myself because I do have technically 2 more official tasks to complete. But for the most part, I think we're solid, and I think we're in the home stretch here. So let's read through these things, and then we'll run through them piece by piece. It seems to be a short read through, so let's do it. Let's get it done. All right, so we got some new privileges, or new credentials, I should say, for this one, which is THM unpriv and then password 321. So let's talk about the first one, the unpatched software portion. So software installed on the target system can present various privilege escalation opportunities. As with drivers, organizations and users may not update them as often as they update the operating system. You can use WMIC to list software installed on the target and its versions. The command right here will do this for us, so it'll dump information that it can gather on installed software. It may take around a minute to actually finish. And the WMIC product command may not return all installed programs. Depending on how some of the programs were installed, they might not get listed here. It's always worth checking desktop shortcuts, available services, or generally any trace that indicates the existence of additional software that might be vulnerable. Once we've gathered the product version info, we can always search for existing exploits on the installed software online in places like Exploit Database or Packet Storm or just Google, right? So using WMIC in Google, you can find a known vulnerability, or can you, I should say, can you find a known vulnerability on any installed product? Feel free to run this at your leisure. I am going to focus on the contents here just to make sure that I don't have an overly long video, but please feel free to run that and do some independent studies and homework and things like that just to sharpen your search skills. So the case study here is the Druva InSync 663. The target server is running this specific version, which is vulnerable to privilege escalation as reported by Matteo Malvica. The vulnerability results from a bad patch applied over another vulnerability report initially for version 650 by Chris Line. The software is vulnerable because it runs an RPC, remote procedure call server, on port 6064 with system privileges accessible from localhost only. If you're not familiar with RPC, it is simply a mechanism that allows a given process to expose functions, these are called procedures in RPC lingo, over the network so that other machines can call them remotely. In the case of Druva InSync, one of the procedures exposed, specifically procedure number 5 on port 6064, allowed anyone to request the execution of any command. Since the RPC server runs as system, any command gets executed with system privileges. The original vulnerability reported on 650 and prior allowed any command to be run without restrictions. The original idea behind providing such functionality was to remotely execute some specific binaries provided with InSync rather than any command. Still, no check was made to make sure of that. A patch was issued where they decided to check that the executed command started with the string program data Druva InSync 4, where the allowed binaries were exposed to be. But then this proved insufficient since you could simply make a path traversal attack to bypass this kind of control. Suppose that you wanted to execute this right here. You could basically do path traversal times 3, right, which is this 1, 2, 3 right here that you see. So it will take you out of this original location back to the C location, and then you give it Windows system, and that's would bypass the check successfully. So fairly simple. So to put together a working exploit, we need to understand how to talk to port 6064. Luckily for us, the protocol in use is straightforward, and the packets to be sent are depicted in this diagram. So this is what we see right here. I don't know if you can see this clearly. So let me see if I can kind of zoom out. Okay, you should be able to see that a little bit better. So this is us, the evil eye attacker right here. So there's the hello packet that's sent, remote procedure ID that's sent, command length is sent, and the command string is all sent. And this is all being sent to the RPC port. So the initial packet is the hello packet. And then in the next one would be the remote procedure ID command length. I would presume that this is happening 1, 2, 3, 4 in that order and not at the same time. So let's see what this reads. It says the first packet is simply hello. So I think that's the case. So the first packet is simply a hello packet that contains a fixed string. The second packet indicates that we want to execute procedure number 5, which is what we see right here. It just says, you know, all these zeros and then 5. As this is the vulnerable procedure that will execute any command for us. The last 2 packets are used to send the length of the command and the command string to be executed respectively. Initially published by Matteo Malvica, here the following exploit can be used in the target machine to elevate privileges and retrieve this task's flag. For your convenience, here is the original exploit code. So we would need to actually essentially just copy and paste this inside of a doc. Or I guess you can pop a PowerShell console and paste the exploit directly to execute it. Okay. This is also available in the target machine right here. So note that the exploit's default payload specified in CMD variable will create a user named PWND, also pronounced as pwned, in the system, but won't assign him administrative privileges. So we'll probably want to change the payload for something more useful. For this room, we're going to change the payload to run this following command right here, the net user pwned, etc. This will create the net user pwned with the password of this and add it to the admin group. If the exploit was successful, you should be able to run the following command to verify that the user pwned exists and is part of the admin group. As the last step, you can run a command prompt as admin, and when prompted for credentials, use the pwned account. For the new command prompt, you can retrieve the flag from the admin desktop. Okay, So the big thing that we want is to modify a few things here. So it's this command right here. So this piece, they said that I could run this inside a PowerShell, but I just need to modify that last bit of it, which is this command right here, the net user pwned add. So I want to make sure that I modify it to include this whole thing so that we can actually be added to the admin account. So now that's what that is going to look like. So we're going to have, you know, everything else exactly stays the same as that script. It's just that we have the net user pwn simple pass, add them to the group administrator. And then just to kind of give you this full version right here, just in case you don't have access to this room inside of TryHackMe, this is the full script. If you want to pause it and zoom in a little bit and then type it out, you're more than welcome to do that. So I'm going to copy this, and we're going to go to our virtual machine here. And actually, so before we even do that, we need to connect to it because I still have not connected to it. So I got to connect to the virtual machine first using these credentials, and then we'll go ahead and run it inside of PowerShell. So let's do our xfree rdp series of commands real quick, and then we'll be able to get into the account. Okay, so there it is, and I've already copied this full command. So if we just go over here and pull up PowerShell, we should be able to just paste that into PowerShell and run the command, and it will create our user for us. That is the assumption here. So once we have PowerShell, I'm going to right click and it basically copies it for me, and I think it worked because it seems like it may potentially have worked. So let's see here. Let's actually go and confirm that. So if we actually go to net user pwned, so net user pwnd, and we can see that we actually have the username, and I am in the local group administrators users. So okay, so it seems like it worked. So since that worked, as the last step, I can go ahead and run cmd as an administrator, and then when it asks me for the credentials, use the pwned account. So I will just close this now because I already have the user. So I will do cmd here. I'm going to open this up, run it as admin, and it's going to prompt me for username and password. So right here, I'm not going to be admin. I'm going to do more choices, and I'm going to create I'm going to use the pwned account, and the password that we put, the username PASSWORD321. What the hell are you talking about? Why is it incorrect? It's literally the password for this thing. Or is it not the password? PASS. Oh, I see. Simple pass 123. My bad. I'm using the password for the login of this room, which is this login. I was using that. That's incorrect. The password is simple pass 123. Okay, that's why it was not working. So simple pass 123. Cool. There we go. So there it is. We're officially used in here, or logged in here, and there it is. I am logged in as the pwned user, and I should now be able to just go into the user's administrator location and look at their desktop, and there's the flag, and just like that, we got it. Nicely done. Super excited about that. So let's go here and paste this flag, and I think there's only one question. Yep. So there we go. Cool. So let us talk about the tools of the trade. There are several scripts that exist to conduct system enumeration in ways that are similar to what we just did. These tools can shorten the enumeration process, the uncovering of different potential privilege escalation vectors. Please remember that the automated tools can sometimes miss privilege escalation. So just keep that in mind, okay? There's also the Bloodhound tool that it's not going to be listed in this, but I mentioned it at the very beginning of the video, and it's a very powerful tool when it comes down to finding a path that you can follow for the users that you would need to log into gradually until you get the highest level of privileges. So these tools that we're going to talk about, they're commonly used to identify privilege escalation vectors. You can run them against any of the machines in this room and see if the results match the discussed task vectors. We have WinPs is a script developed to enumerate the target system to uncover privilege escalation paths. You can find more information about this and download it, either the pre-compiled executable or the bat script. It will run commands similar to everything that we did in the previous task and print their output. The output from the WinPs can be lengthy and sometimes difficult to read. This is why it would be good to always redirect it to a file. For example, running it and then turning it to a file so that you can go ahead and read through the file or search through the file. You can download it directly from the GitHub of PEASS-NG/ same thing. And then you'll be able to find the WinPs download. So there's that. There is privs check, privs check. It's a PowerShell script that searches common privilege escalations on the target system. It provides an alternative to WinPs without requiring the execution of a binary file. And you can download that at this specific location, which is, again, you guessed it, GitHub. So itm4n privs check, and then you'll be able to download the script. To run privs check on a target system, you may need to bypass execution policy restrictions. To achieve this, you can use this set execution policy commandlet as shown below. And if you wanted to do it, you could do it like this. If you're inside of this video, inside of this room in TryHackMe, all of this would be available to you, by the way. But in case you want to do it yourself, you can go ahead and pause the screen, 1, 2, 3, and then go ahead and download it, or excuse me, run it. Then we have WesNG, the Windows Exploit Suggester Next Generation. Some exploit suggesting scripts like WinPs will require you to upload them to target systems and run them there. This may cause antivirus software to detect and delete them. To avoid making unnecessary noise that can attract attention, you may refer to the WesNG, which will run on your attacking machine. And it's a Python script that can be found and downloaded. Where do you think it is? It is on GitHub. So it's the bits-admin/WesNG location on GitHub. And once installed, before you use it, type the wes.py update command to update the database. The script will refer to the database it creates to check for missing patches that can result in a vulnerability you can use to elevate your privileges on the target system. To use the script, you will need to run the system info command on the target system. Do not forget to direct the output to a text file, and because you will need to move it to the attacking machine. Once it's done, it can be done as much. So you can do set system info on the target machine, then take that text file, move it to the attacking machine, and then run wespy on the text file. And of course, we have Metasploit, the Meterpreter shell on the target system. This is one of those amazing things. I canceled it, but there is the multi-recon local exploit suggester module to list vulnerabilities that may affect the target system and allow you to elevate your privileges on the target system. So these are just some of the tools that you can use in your journey of privilege escalation. And for future pen testing exercises, Bloodhound is another really good one. And you can learn more about Bloodhound by going to the CompTIA Pentest Plus training series. I have no idea which video it was that I covered it on, but I know that it's inside the CompTIA Pentest Plus training series. So if you actually go ahead and search the channel contents, I think you'll be able to find it. So if we search through the channel contents for Bloodhound, it's definitely not episode 0, because that's kind of like the intro to everything that we were talking about. I want to say it would be episode 13 for vulnerability discovery, or episode 16 for authentication attacks. I think either of those works really well. Vulnerability discovery and analysis. So I think it is the episode 13, because episode 13 is a part of vulnerability discovery, and this one down here is the full module 3 that has vulnerability discovery and analysis. So I think it's in episode 13, I think. But at least this narrows it down for you. You can go ahead and search for Bloodhound, and then you'll be able to find that specific video where you can learn more about Bloodhound. And that is it, my dear friend. So let's go through the conclusion, some final thoughts, and we will be done for today. So in conclusion, we covered a lot of stuff for privilege escalation on Windows today. There are also even more videos and rooms, I should say. There are more rooms available on TryHackMe that can teach you very many things on Windows privilege escalation, and these are all super freaking handy. But basically what we talked about, just to kind of give you a nice review of everything. was obviously just what privilege escalation is on Windows. We looked at some of the easier stuff, so harvesting passwords from actual usual spots or other quick little low-hanging fruit type things. Then we looked at service misconfigurations. We looked at the various privileges, and the privileges one was the one that I had to restart the machines, but that was also relatively easy to execute once the connection was solid. And then abusing the vulnerable software, and then we just looked at some tools of the trade, some stuff that can potentially help you automate. And then of course you can go ahead and look at all the content that's available on the channel to try to find more information around these things. There's literally a Windows playlist that is available on this channel that has a bunch of other videos. So there are resources, there are a lot of resources that are available to you, and we talked about just a handful of them in this video. And I think if you take your time, and maybe, because I do talk fast, because when there are big rooms that I have to complete and there are long videos, I read through them pretty quickly. So you can slow down the video using one of the settings inside of the YouTube video that you're watching on YouTube. You can actually slow it down and it'll make me talk slower. And from there you can hopefully follow along a little bit easier, and the information, you can grasp the information a little bit better. But apart from that, you can always just rewatch sections, you can always rewind things, and just go through everything that you need to. And my recommendation always is to do these things multiple times, do all of the independent research portions of it, read through certain things. If you're serious about cybersecurity, if you're serious about pen testing and ethical hacking, if this is just something that's a hobby to you, that's all good. There's nothing wrong with that. But you're gonna spend a good amount of time to go through your initial learning curve so you can get better. One of the, I started technically in 2023, at the beginning of 2023, and I started this channel at the beginning of 2024. And I have been recording consistently since the beginning of 2024. So January 2024 is when I started recording, and I've been recording consistently. And one of the reasons why I feel as confident as I do with some of these contents, with these topics, is because of the fact that I have done so much time investment into these topics. And it helps me gather that a little bit better. So if getting better at hacking, if getting better at cybersecurity, security engineering, or whatever, digital forensics, whatever the path is that you're most interested in, system administration, it doesn't really matter which topic it is or which subcategory it is. If getting better at this is one of the goals that you have for your studies, for your professional life, for your life in general, because this stuff actually really is helpful for general life as well. As a everyday consumer going through the modern world, there are going to be constantly people trying to hack you and scam you and spam you. So all of this stuff is actually really helpful. And if you want to get better at it, then it requires time and energy investment. And I don't expect you to be a full-time student, because I don't know where you are in the world. I don't know what your situation is like. You may be married with kids. I know people that are a part of our community that is a grandfather with kids and grandkids and a full-time job. So that could be you, or you could be a full-time student, right? And you may have all the time in the world, and you still want to go hang out with other good-looking people, and you still want to go party and all those things. But you got to find the time, right? You got to try to find some kind of schedule for yourself where you can consistently dedicate the time, hours, the energy that's required to get better in this field. And if you do, you will get better. That's all I can say. It's not that complicated. A lot of these things, the first time you see them, seem complicated. But when you see them repeatedly, then all of a sudden your brain starts to kind of wrap around it, especially if you're one of the younger people, because your brain is still soaking up so much information, and it's such a powerful tool that you have, unless you're getting, drunk all the time and you're destroying your brain, which I totally get it. I've done that. So I'm not here to judge you. I'm just letting you know that it will affect the way that you can retain information. So if you're young, then your brain is soaking up information all the time. and you can go ahead and use that to your advantage and learn fast and retain a bunch of information and get really good really quickly and then blow everybody else out of the water. So totally up to you what you want to do with it. I just want you to know that there's something called condensing time frames. So if somebody studies 3 hours a day and you study 30 minutes a day, then they're going to beat you. That's basically it. If somebody studies 20 hours a week and you study 2 hours a week, they're going to beat you. And then vice versa, right? If I study 2 hours a week and you study 20 hours a week, you're going to beat me. And that's how it should be. You deserve to beat me if you put in 20 hours and I put in 2 hours. That's what it is, right? There is no favoritism when it comes down to information. Everybody has the same power. Everybody has the same, maybe not the same power, but everybody has access to the same information, and you have the same number of hours in a day. And maybe you need to study more to retain something that somebody else can study for 30 minutes, but that's because that's a part of their power. But diligence is one of those things that you have to train and you have to practice and get better at. Persistence and consistency, all of those things you need to get trained so that you can get better at it. And the only reason why I'm giving you all of this information now is literally just because this is the last episode of the Junior PenTester training series. So I want to try to encourage you to put all of the time and energy into it that it deserves, that this content and this world deserves. Because if you respect it, if you respect this world of IT, cybersecurity, engineering, scripting, pen testing, this world of technology, if you respect it, then it will return that to you. It will return that energy to you. And you will be better than the 90% of people that are just treating it casually. It's the last thing I'm going to say. So hopefully you got value out of this video and out of this training series. If you found value in this video and if you would like to get more videos like this one, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. We're officially done with Junior PenTester, but there is the CompTIA PenTest Plus training series that's running, and then there is a bunch of other stuff that's going to be coming out in the upcoming weeks and months and hopefully years. So I really hope that you'll stick around and you'll become a part of our community and join us as we go through this journey. If you have any comments or questions about what we talked about today, drop them in the comments section below and I will get to them as quickly as I possibly can. I check the comments from my phone, so I am pretty good at responding quickly. And I respond to everybody. Sometimes I miss them, but I will go through the comment section on my computer every once in a while just to kind of scroll through and see which ones I missed. But I do try to get to everybody's comments so that nobody falls through the cracks. And as it stands right now, I'm replying to everybody. I don't know what it's going to be like when we hit 100,000 or 1 million subscribers, and I'll still try my hardest to respond to everybody. But as it stands right now, for now, I do respond to everyone that comes in. So if you have a question, if you have a comment, whatever it is, drop it. And if you have any requests for content, drop those, and I will get to those as quickly as I can as well. Feel free to browse through everything that we have on the channel. These portions right here, these are all of the CompTIA playlists. The Linux Plus one is very well received. A lot of people love it, and a lot of people have used it to study for their examination, and some people have actually used it to get jobs, like real world jobs. So this definitely helps. PenTest Plus is the one that I'm building out right now, and I think it should be done hopefully within a month or two. Definitely by 2 months I think it'll be done, but I'm going to try to get it done sooner than later. Network Plus already done, Security Plus already done, and people have used all of these things to actually pass their examinations. And the most recent one was actually a comment that we got from Pause Zero for getting their PenTest Plus examination passed. And the note right here says that the notes were very extensive, so thank you. So this actually really helped. Like, these things really help. And for people who join Hackaholics Anonymous, they get access to the notes document that I use for the lectures, as well as the slideshows and practice exams, and if there are scripts that are involved, the scripts. So everything that goes into developing these training series, you get access to because you're a part of Hackaholics Anonymous as an agent level member or above. These are the Hackaholics Anonymous videos that are available here, and I mean, just a bunch of other stuff that's available. And you can always either scroll through the content to find something that's useful for you, or you can just go over here, do this little search button and search for the content that would be, you know, something that you're actually looking for. Apart from that, make sure that you like, subscribe, and turn on the notification bell to get notified the next time that video comes out. And of course, drop a comment if you have any comments or questions. If you're serious about your SciSec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later.